Students, what we will see today, we will see the three different topics, starting by the using the pipes as a data stream and exception handling for the input outputs. Although we have seen, but as a revised purpose, we will see again. And next part, we will see the directory handle. Directory handling means working with some directories, how we can do. Regarding the working with the directories, now I'm using with the Google Colab, but in the next time, what I will do, I will also give a demonstration over the Jupyter Notebook. Because when we need to connect the database, then Jupyter Notebook will be applicable. Over the Google, by using the Google Colab, it will be very hard to connect because some internal internal functions are required to access. So from the Google Colab, it is not easy to access. So for regarding that one, we have a Jupyter Notebook by which we will try to connect the database. That's the beauty of the Jupyter Notebook, and it can easily handle. So we can do that part only. So let us start the first part using pipes as a data stream. So apparently I will write something over here. First I'm writing using pipes as a data stream. Using pipe as a data stream. Basically, it is just managing by only the simple program, so you can easily understand by the parent-child relationship only. So pipe is basically is nothing which is only functions that is used to find the create some pipe actually. So pipe basically method. Basically, a pipe is a method to pass information from one process to another process. So what we are doing in the data stream, we are passing information one point to another point. So that is handled by the input, output, and reading the data, writing data. So how we can read the data from the child process, how we can pass the data from the parent class or parent process. So this is handling by the only the pipe. That's why I'm giving the name pipe as a data stream. So with the help of the pipe method, you can pass the information into the message format as well, but it is not hardly used by. It is applicable only those programs which are required to managing the parent and child relationship, except to the inheritance. So OS module in the Python programming provides functions for interacting with the operating system. So how we can use the OS module, I will tell you. OS comes OS comes under Python's standard utility modules, and this module, especially the OS module I'm speaking, provides a portable way of using operating dependent functionalities. So all the functions in OS module raise OS error. That's the point. So because raise is basically a concept we have seen into the exception handling as well. That is a point you have to keep in mind. All functions in operating system module, OS error in the case of invalid or inaccessible file names or the or maybe the end path we can say, or other arguments that have the correct type but are not accepted by the operating system. So regarding this one, what we will use a very simple thing that is known as the os.pipe. So this is the method we will use. Okay, so this method we will use. I'm writing here in front of you as a proof parallelly. So os.pipe is method in Python is used to create a pipe. A pipe is a method to pass information from one process to another process. It offers only one-way communication, and passed information is held by the system until it is read by the retrieving process. So how we can do? The syntax would be very simple. os.pipe method I just written in front of you, and parameter, no parameter is required to over here. And return type would be it's this method returns a pair of descriptor R and W. R means read and write. So usable for reading and writing respectively, definitely. Regarding this one, I would like to explain a simple program. So let us understand by help of a program. This is a simple concept we are looking for. So first we need to import the OS module. So that is the import OS. We need to write just like this. What we are doing, we are trying to importing OS module, as I'm speaking many times today. OS module. So this is the OS module we can read. Okay, so from this point we can see. Now we need to create a pipe. So how we can create a pipe? A pipe basically a method, as I told you. A pipe is a method to pass information from the one process to another process. Okay, so how we can create? With the help of the pipe method we can do. So if I'm writing os dot pipe, so what it will return, as I told you a couple of seconds ago, it will return the two type of the parameter, one is R and W, which is known as a descriptor, which is following by the reading and writing information. So it will return two type of the parameter. So I'm just writing R comma W equal to os dot pipe method. So this method will return the two parameters. One is R and W, and it means, so first you can take the A, B, no issue. So R means reading and W means writing. This is the point we need to keep in mind. Okay. For your helping purpose, let us print R, and let us print W what we are returning. So for the proof, I would like to see. Let me execute this code in front of you. Let us see what we are returning, what we are getting. That's the point we have to keep in mind. Step by step, we will see. So the picture will be clear in our mind as well. Let us see what it is returning. In between, I am speaking the return file descriptor R and W, as I'm speaking over here, can be used for reading and writing respectively. So we will create a child process, and using these file descriptor R and W are the file descriptor, the parent process will write some text and the child process will read, and the text written by the parent processes. Let us see what we are getting. We are getting the something 57 and 58. Can anyone tell me right now what is this 57 and 58? We didn't pass any number, we didn't use anything. So what is this one? Can anyone tell me right now? If you have little bit idea about the Linux programming, Unix programming, then you can give the answer. Just tell me. Now it's changed 61, 62. Can anyone tell me right now what is changed? What is R and W? Read and write. So what is the 61, 62, 57, 58 is coming? Tell me anyone. Yeah, can anyone tell me right the answer? Yes, speak. See, if you remember, I'm speaking the process, and so 61, 62 is nothing, which is the process ID actually. The process ID. Okay. This is a process ID for reading. Okay, so R means process ID for reading, it will return. And this is a process ID for writing. That is the point. Please keep in mind. These are the small question for the interview anyone can ask you. Okay. So now let us create a child process. So how we can create the child process? It's a very simple concept. The child process can be created by the fork. Fork is basically a system call. If you have gone through the operating system, you must be aware about the what is mean by the system call. System call are nothing which are the internal command or internal set of the instructions which is executed by the systems only to pass some information from the its processes only. So it may be the n number of the process. Some process could be the parent, some process could be the children or child process. So from this scenario, we can say we need to create a child process. A child process can be created by only the one system call, that is a fork. Okay, so how we can create PID? I'm writing here os dot fork. So create a child process PID equal to os dot fork I have created. So PID is greater than represent the parent process. Okay. So let us check what we are getting. PID. What is returning? 134. Okay. And one thing I would like to write over here, create a child process. uh, okay, now I have created. So PID greater than 0 represent the parent process. That's the point. If PID is greater than the 0, it means we have the parent process right now. So if I'm just continuation way, I'm just like to write if PID is greater than 0. Let us check. Then what we have to do? The parent process close the descriptor R. So how we can write? os dot close, and we need to pass the R. So the point what is, if PID is greater than 0, the OS dot close I'm using, and what I'm passing the R. I'm passing means what I'm passing the R descriptor, that is for reading purpose. So parent process will close the descriptor R. But write some text on the descriptor. So what we can do, we can use the W. So regarding this one, we have the continuation part. I would like to write some statement over here for helping purpose to you. Uh, I'm giving a message. Print. Current process is writing. Current process is writing. This is a message I'm giving. So what it can pass? It can pass the some temp variable I'm taking, and I'm writing. Uh, just try putting my name over here. Okay, nothing else. Just only putting my name over here. And what I have to do? Os dot write. Os dot write with the help of the script W. And what is the data? Temporary data I need to write. Okay. This is please. Okay. This be so this would be here. Indentation should be proper. Yeah. Let me explain once again the step. If PID is greater than 0, then the parent process will close the descriptor R. So parent process will not read anything. It will write some data. Okay. That is the point. And what we have written. So I'm just writing print uh, written written data. Written data. Written data would be temp dot temp dot decode. Decode is a function which is used to record the message that will show the all the information. Now in between, what I'm just let me check, because PID is already greater than 1. So let me check it is working or not. So we are okay. Okay, I got you the point. So writing function is not writing. Okay. This data we are using a byte like object required to string. Okay, so we are using a string. So we need to use a B. Um, B used to convert string to byte. Please keep in mind this is a small thing I missed. So I'm writing here. Again, it's still coming. Bad file descriptor. I'm passing closer. Os dot closer. Yeah, it's perfectly. I'm putting os dot closer. Where is os pipe? Okay, R I'm using. Okay, so same I'm getting. Bad file descriptor. We are passing the character file descriptor. B. It is no issue. If I'm not closing, let us check. Okay, so it means no need to close. Okay, so if you want to clear, then you can use. But I think it should be closed. But no issue. Well, still we have continuation work. So the parent process is writing. So what is writing? It is writing the data on the our point. So decode method is nothing. Decode method will represent the data into the byte converted form. So that's why we are using decode. Okay. So after then this one, let us see the else part. Else part, I will like to write for uh, W. So let us close W. If I'm trying to close W, let us check it is working or not. If it is not working, then we can leave it, no issue. Then read the text written by the parent process. So let us the text written written by the parent. So what is parent is written? Parents written on the data into the temporary format. So temporary variable we have written. So how we can read? So I'm just putting a message. Uh, child process will returning. So here child process is reading, not returning. Reading. Time to read. So reading. What is will reading? I'm taking one more variable temp2 equal to os dot fd open, and we need to pass r only, yeah, because we are using the data for the reading purpose. Temp dot os dot fd open. Fd means full descriptor open. Actually fd means full descriptor open. So this fd means full descriptor, and let us print the information. Print the information what we want to print. We want to print the read data. So let us check what we have done. Our variable is temporary 2 dot, and we can also use the read method for our easiness, as we have discussed this method many times. And let us check what we are getting. Okay, so parents process writing and we are reading. If it is PID is lesser than 0, then we can go to this part. Let us move to the change this point and see else part is executing or not. Yeah, so it means I need to check the this part. So this could be not FD. So without the open, let us check it will be applicable or not. Again, this is the problem. So I need to, yeah, this one. Path should be string byte, or so this should be string. That's why I put it over here, the dot string, and then the so open. So that's why I'm taking the FD. If I'm putting once again over here, see, I have been observed this some things are depend on the some browser as well. If I'm using the Jupyter notebooks, it's perfectly working, but I'm using this one, so it's just unable to do so correctly. I'm doing the correct work. It should be FD open. It should be FD open. What error we are getting into bad descriptor argument, and okay. So R is our descriptor which is returning by. Now let me use this one. See, still yeah, read text written text by the parent. The OS fork is generating. R and W I'm using. Let me try to execute this code once again. 61, 62 PID. Let me generate. Now PID is coming 222. So PID less than this one, so condition will be false. So it will jump to the else part. Yeah. So now this message is printing right now. So child process reading. Child process reading. Okay. So this is the point we got the message. Child processing reading, and it is reading the data what we have passed. So there is no error so far, but it's stuck over here. So it continuously executing, and you can see at the bottom side executing 39 seconds for saying. So the program is just stuck in a situation. This is a dialog situation, we can say. So still is still unable to read some more information. So all files and contained with the various directories, and Python has no problem handling these two. So the OS model has several methods that you help you can create, remove, and change the directory. That part. Let me come to the point. Okay, so now it is just stuck in a situation, so I need to stop. Okay. So it's a keyboard input interrupts we are getting. So it's stuck in a situation. Is again reading. If I'm just moving this value, let me execute the whole the code once again. Executing perfectly. Now PID is what is PID? Yeah, 47. So condition will be true. So it will print the parent process writing and everything will be on the correct. But the on the else part, it is also doing the correct thing. But point is over here, it is stuck in situation where we are getting this thing. If I'm putting else part, let me take just randomly. I'm just taking this one. I'm just writing. Check. Yes, still it is stuck in situation. Chat process is trying to read from the our information, but still it is unable to read. It's a situation. Okay, that's a problem. So this kind of example is telling to us with the help of the pipe, we can use the data stream. We can pass. So here what we are doing, we are using the write. If you remember the write function, if you remember the open function, here we are using the FD open, which means full descriptor function. So if you remember these kind of the function, these function are already used by us into the previous classes to know how to read the data, how to write the data. Okay, that's the point. So I'm writing over here. I'm just stopping this program and I'm writing the PID only. Okay. Now again, I have to regenerate. Now this one. Now again. Now it is perfectly run. So see this pipe symbol basically directly deal with the system's call. So that's the problem. So this is a small things by which you can easily understand how we can use the pipe to understand as a data stream. So that's why I told you many. If you remember my words, as I told you at the time of the starting the class, this pipe symbol is not mostly used. This is used when we are working with the systems files or we are reading the information from the systems call. But nowadays Python is mostly applicable to the application program oriented, but we are not dealing with the systems programming. But when we need to do that, how we can do? So this data stream we can use like this way by the help of our OS model. And how we can import the OS model? Just like this way, import space OS. And with the help of the pipe, we can create a pipe. Pipe means just nothing, which is a method that define the two descriptor are read and write, which is used to read the information, write the information over the our processes, and we can pass one information from one process to another process by the help of the pipe method only. That's it. That is the point. So this is just basic idea I have just given to you all. Yeah, it is clear to all right now. Yes, tell me anyone who need to ask any question so far. This is a concept which is a part of the syllabus as mentioned. So that's why I put it over here. Yes, anyone who need to ask any question? I have given the live demonstration to you. Yes, tell me. Anyone? Else we can move to the other topic. Yes, anyone who need to ask any question? Or shall we move to the next topic? Okay. So I'm moving to the working with the directories. So all files are contained with the various directories. Yeah, it's very true. And Python has a no problem handling these two. We can also handle the directories. So the OS module has the several methods as you have seen a few couple of minutes ago that helps to create or remove and change the directories. So let us understand the thing step by step. First, I'm writing here, uh, working with directories. Directories, please keep in mind. Regarding this one, what we have to do, we have to understand how we can create the directory. So can you tell me right now what is the steps what we have to do? First, we need to create a directory. Okay. Then after creating directory, we have a right to remove the directory, or before creating, we have to move into that directory. So how we can move? By the help of the changing directory. Changing directory. This concept is known as a changing directory. And then after this one, what we have to do, we can also remove the directory. Can anyone tell me right now what is mean by the changing directory? Yes. Can anyone tell me right now what is mean by the changing directory? Okay. No problem. I got the answer from your side. Don't worry. Your silence speaks to me a lot. So okay. So what I'm doing? I'm explaining. No problem. So with the help of the make directive method, we can do. So I'm writing. We can use mkdir method to create a directory. Okay. So let me explain the example by which the picture will be clear in your mind. You can use the mkdir method of the OS module to create directories in the current directory as well. This example I'm showing right now on the Google Colab. If time permits, then I can explain this example on the Jupyter Notebook. Okay, so we can also move to that part. We can also see. You need to supply an argument to this method, that is mkdir, which contains a name of the directory to be created. Let me take the example over here. So where the directory will be created, directory will be created into the its memory only. So I would like to explain the example with the help of the import OS. Okay. So that's why what is the OS is required. The what is the OS module I have already explained. So you can see the OS routine for the NT means that is our new technology on network, or POSIX depending on what system can do. So we can do like this way. So this operating system module is more important to OS module. Okay. With the help of that part, we can also create a directory. So I'm creating a directory with the help of the mkdir. It's os.mkdir, and I'm creating a directory in front of you for the my name only. Okay, that's it only. Okay, after this one, I'm executing the code, nothing else specially. So here you can see my directory is created. Let us check how we can say directory is created or not. So how we can say that our directory is created or not. Okay. So regarding this one, how we can check? So we can check what is the present current working directory. So there is a method get chw. Okay. Regarding this one, I'm writing out a simple concept import to know present working directory. Regarding this one, how we can know? It's a very simple command import os dot get cwd. What is cwd? Current.
Working directory.
Yeah, super working directory. So let us know what is the current working directory. We are getting is this one. So this is coming from the our only the Google Colab only, because we are running this code over the internet only, so it is giving only this point only this directory by default. We can also run this code on the Jupyter notebook. So what is the directory we have, it will represent automatically from your system. So with this command, you can also check it. I suggest to all the students use the different IDs to check what is the path we are getting. Okay, so this one we can get it. So right now we have created directory that is behind. Okay, so from this point we can also know that this directory we have not entered. So if you remember the my statement in the DOS command, okay, what is mean by the DOS command? If I'm creating any directory, then I need to enter that directory. Then I can create the number of the files. Without entering the that directory, I am unable to do so. So regarding this one, what we have a change directory. Change directory is what actually? Change change directory means change directory means to enter into that directory, to the directory where you want to work. It's just like similar to that. If I'm not entering inside a home, then how I can explore the home? So let me enter. So with the help of change directory, I can do. Regarding this one, the simple syntax import OS. I'm taking OS dot OS dot. What I can do, I can take the ch directory. Okay, chdir method by which I can do. Okay, and here I need to pass the directory name. What is the my directory name? If you remember, as I've created a few couple of the minutes ago, Birendra. Okay, this command will help to change the directory. Chdr means use chdr method. Okay, this is a please keep in mind. If I'm executing this code now, if there is an error, then error will be reported, else no error will be reported. I'm again copying this code, okay, to check whether I have entered or not into that directory. To know the current working directory status, I'm just pasting the same code over here in the next cell and see whether I have entered into the directory which is created by me or not. So let us check. So as a proof, you can see now I have entered into the my directory which is created a few couple of the minutes ago in front of you. That is BN directory I have entered. So what is my present working directory or current working directory? That is now BN. That's the point. This is the important point you have to keep in mind. Okay, now it is clear right now. So what is the CWD method? Get CW method. The get CW method gives a location of the current directory. This is the point. Now it is clear. Anyone who need to know? Anyone? Yes. Anyone who need to ask any question? So what we are doing, we are playing with the directory actually. We are working with the directories in the Python, how we can create it. Okay, that's the point. Now let us remove. Okay, uh, to remove the existing directory. Existing directory. If I need to remove the existing directory, then how I can remove? That's the most important point. So regarding the same, we have to use rmdir command. Rmdir command, not command, is a method we can say. Okay. So just like this one, import os dot. I'm writing rmdir and I'm putting inside the bracket my directory name, that is this one, which is created by me few seconds ago in front of you. And let us check what we can do. So the rmdir method deletes the directory and which is passed and the argument in that method. Before removing the directory, all the content in it should be removed. So that's the important point you have to keep in mind. Let me remove this directory and see it is removing or not. Oh, it is not removing. We are getting the error. Can you tell me right now why we are getting the error? Why we are getting the error? No such file and directory. Answer is in front of you, but I need the answer. Yes, tell me anyone. Why we are getting the error? In the present working directory, I shown you we are in this directory. We have removed this directory, but still there's no file and such directory be run.
Because there exists no Virendra. There exists one content, and then inside that we have Virendra, I guess.
Yes, we are already inside the Biran directory, so that's why we are not able to remove. So what we have to do, we have to come back to our previous directory, or we can use the change directory command, so we can move to the back. So what we have to do, we either we can pass the entire path, so we can also remove it. So what I'm doing, I'm just doing nothing. I'm just copying this code, and the next code I'm just pasting. And rather than this one, I'm passing its entire path as it mentioned over here. So I'm just copying and I'm remove. Yes. And let me check it is remove or not. Yes, now it's perfectly working. Okay. So I have given the entire path over here. So my directory will be removed. Okay. From this point, I need to check what is my present working directory. So I'm copying this code in front of you and just pasting over here to know what is my present working directory. So now this is the point what we are getting. This error is reporting by the our operating system. So root internal Python error in the inspect modules. It means there is no directory and files we have right now. So we need to create again one more time file and then do. This is the error we are getting from this point because we have removed the file. Sorry, directory, not file. So these are the small thing will help you to understand how we can create the directory and files. It is just like similar to create directory file in the Python and Unix as well, DOS operating system as well as in the Linux or Unix operating system. So this is the small thing which help you to understand how we can create a directory. Now you can explore the many things by which you can do. You can create a file. You can do. You can also create a file. Yes. You can also create. You can also create a file. You can also create the multiple directories as well. It's your choice. Okay, so far it is clear to everyone how we can create a directory. Yes, tell me the answer.
Yes, sir.
Okay, so if I'm thinking about the next topic that is more important to us, that is we can say exception handling. Exception handling, although I have already explained. Okay, so we can understand the point is very simple form. So how we can understand the exception handling? If you remember the my words, exception handling can be handled by the our try, catch, block. So with help of the such blocks, we can also do this one. So now directory is created. This one is created. Okay. So this complete task we have done. So now I would like to come to the one more thing I'm remembering. We can also create the multiple directories. Okay. So instead of the mkdir, we can also put the make dirs. This is the important concept by which we can also get the multiple directories by the simple or one command. We can also create the subdirectories as well. So there are lots of the command which help you to understand everything. And we can also join the multiple command as well. Okay, so there are many things which help you to understand how we can create. So now I would like to come to the next point which will help you to understand what we can do. Python input output exception handling. So I'm writing a very simple code and which will help you to understand what is the input output exception handling. Although we have seen, although we have seen, but here I would like to give you some more idea because this will be more applicable to you while creating preparing a project or designing any project in the Python programming. So I'm taking a variable a equal to 100. Suppose I'm this is a variable I'm taking, and I'm just taking a simple this value if a is greater than 200. This is a simple syntax, and it should print a message. What it should print message? Okay, it's a very simple message. I'm just want to print a message. Hello. Now I'm executing this code, so there is no issue. Can anyone tell me right now why we are not getting any error? Is it correct or not? And if I'm executing this one is a multiple zero like this one, I'm executing, then it will print. So because initially we have executed the code which had false condition, but we don't have any else condition or else part, so nothing is to be printed. But this time the our condition is true, so it is printing the hello. This is only this concept I'm speaking right now. But we need to check everything. So for checking, we have the input output exception that we can manage. Regarding this one, I'm just remembering some terms that is syntax error or exception. So what is syntax error? As a name suggests, this error means syntax error is caused by the wrong syntax in the code, and it leads to the termination of the program. That's the point. So in our code, we don't have any error. Okay, that's the point. We don't have any error. We have an exception. Our programs, our true condition is false. Then we didn't get what we are getting. But what is exception actually? Exception are raised when the program is syntactically correct, but code resulted in the error. So this error does not stop the execution of the program. However, it changes the normal flow of the program, or nothing else especially. So you can see this program. There's a very no problem. Let me put the next program, then you can easily understand. I'm taking the same variable b. Okay, v I'm taking the 500, nothing else, a small variable. And what I'm doing, I'm just trying to divide r is my result variable, r, yes, I'm writing result variable equal to b divided by 0, and I want to print the res, and I'm executing this code, and let us check what we are getting. This is generating the exception. Actually, this is not an error. Here we are getting the exception. What is the exception we are getting? You can see zero division error. Division by zero is not possible. So during the handling the above exception, another exception may also occur, depend on the problems. Okay. So we need to keep in mind this division, zero division error is coming, but that is not error. That is a exception. So logically, we don't have any syntactical error. But here we have a logical error. Syntactical error means there is no syntactical error, no syntax is absolutely right. But here we have an error which is known as the exception, not error, exception. So this kind of the thing will help you understand how we can manage the thing. To manage the thing, if you remember the my words, so this I'm speaking once again to all the people as a revision purpose. Try and accept statement will help you to catching the exceptions only. So try and accept statements are used to catch and handle exception in Python programming. The statements that can raise exception can kept inside the try block or try clause, and the statements that handle the exceptions are written inside the except clause. So if you remember the my words as we have seen the previous class, try and catch a block or a clause. So try we have used and catch also we can use. Here I'm writing a very simple thing. So let us check how we can understand. For a helping purpose, I'm just taking the variable a. I'm putting the random variable 4, 6, 7, 8, 9, something like this one. A simple program for the try block. So what I'm trying right now, try. I want to try to print the second element. Element how I can print? I can pass the its index value 3. I'm passing. It's not yeah. So 3. a 3, and let me put this one and this one. Try print this one. Okay, and I want to print another, that is a 0 1 2 3 4. Okay, so if you just see how many indexed we have, if you remember that on the 0th index we have a 1 a 4 value. In a one index we have a 6 value. In a second index value position we have a 7 value. And third index, what is the value we are having? The 9. So third index 9 will be printed undoubtedly over here. Okay, but it will print the 9. Okay, it will print the 9, but here the exception should be generated. So exception will be raised. Okay, will be raised. This exception can be catched by a catch block. Not catch block. Here we have a except. Here we have a except. Okay, let me write correctly. Yeah, and this one. And now I'm printing a message. If should be small e actually. Okay. Now print missing or out of bound index value. Just you can write whatever you want to write. You can write. Let us check. So here what we are getting, the printing A9 perfectly no issue. But again, when the exception generated, then it just jump to the our except part, and out of the index value will be printed over here. That's a simple thing. So this is just handling by the our except clause. So catching specific specification, so the multiple exception we can also handle. Okay. So multiple we can also handle. So how we can handle? It's your choice. You can also uh, design your code as according your need. So whatever you want to do, I'm just taking another example for my curious, remove the curiosity to all the students. What I'm taking a small program. Just finding the function uh, define temp. In this function, I'm just taking a variable t, okay, and nothing else specially. And in this function, I need to check if t is less than 4. Okay, if t is less than 4, then we can say jad is equal to uh, t divided by t t divided by 0. So let us check. Okay, if t divided by 0, nothing else. Okay, and now print the value of the print z. These simple things I'm doing, nothing else. And the try block, the try clause or block you can say, I'm calling a temporary variable and passing the 4. Again I'm calling the passing the temp 2 or 3 you can check. Okay. So multiple exception I can also handle, as I told you. So I'm taking the same example. Multiple exception we uh, can also be handled. Now this is simple beauty points. So how we can handle the multiple exception? Yes, with the help of the except, we can also write the exception. So here I'm just writing the 0 divide divide error, division error, not divide. Yeah, zero division error, and now put this colon. So print zero divide by error we have. Okay, I'm just writing this way. Multiple exception I'm speaking right now. So another exception we can put like name error. Okay, so this one I can write, and we can print the name error. So we can also print the name error. And this one I'm just taking like this way. Name errors uh, occurs and handled. Okay. Let me execute this code. What we are getting. So zero divided by error we have. Okay. So if we are not dividing by zero error, let me just put the over one over here and see 3.0. So I'm printing 3.0 when I'm passing the 4. So condition will be false. So the loop will be terminated. Okay. The 3 will pass over here. Condition will be true. So it will printing a 3.0. Yes, perfectly. Here I'm just passing divide by 0. So we can also. So here what we are getting here divide by 0 is coming 0 divided by error because what happened here multiple exception may generate but here I'm generating only the one. So this syntax is telling to us we can also raise the or we can also raise the multiple exception. If it is just try catch will generating the multiple exception then we can also handle also those exception. So it's our choice how we are doing. So how we can write regarding the multiple exception, what are the list of the exception? I will share to all the people. Then you can see what are the different kind of the exceptions, parameter values we have. So here zero divide division error. I can't write the zero divide error, zero division error. So these are the sub keywords we have to keep in mind. So exceptions keyword I will share to all the people. Then you can make a program accordingly shoots whatever you want to. Here I'm just giving the idea how we can write the program only. Okay, so this is the beauty of this class we can say. So try and else clause we can also take it if you remember the my statement. Okay. So if I'm trying to this one, I'm calling this one, and if the divided by zero is occurring, suppose divided by zero is also occurring, then we can also use the else. Okay. So we can also put the else. So else print by just something just like this one, and else keyword will come at the end. Please keep in mind. Yeah. For the accept it will come. Yes. Okay, let me execute this code. When we are getting the exception, if you remember the my words, I'm repeating once again as told you in the previous class. When we are getting the exception, then else part will not execute. But finally will also execute. If you remember the my words. So let me check this program by changing the finally. What I'm doing, I'm just changing nothing. I'm just doing small changes. So this one I'm putting the finally. I'm executing the same code. It will print also the by. So what it means, what is telling to us? Else part will execute when when all the conditions fall false, no exception are generating else. But when the exception generating, our program will terminate. If you remember the my word, when any exception is generating, the all program will be terminated. No else other part will be executed. But in the finally keyword we are using, then what happened? Exception are generating, but until and unless the finally keyword will have to print the statement. That's the beauty of the finally. So when we have to use the else, when we have to use the finally, it's your choice, it's your program demand. You can make this accordingly. So Python provides a keyword finally, which is always executed after the try, catch, try or accept blocks. The final blocks always execute after the normal termination of the try or after try block terminates due to some exception. No issue about it one. This is the simple things we have to keep in mind. Okay, so that's why we have this statement over here. Raising the exception is basically a new things. If you remember the my words, as I told you many times, so raising exception. What is raising exception? Raising exception is nothing basically. It's a statement actually. So the raise statement allows the programmer to force a specific exceptions to occur. The sole argument in the raise indicates the exception to be raised, and this must be either an exception instance or an exception class. A class that arises from the exceptions, we can say like this one. So regarding this raise exception, I would like to tell you something by the simple program. So I'm speaking the raise exception. I'm writing. Okay. Theory I will not speak over here. So theory you can read out from the my notes only. So I will share to all the people. You can go to that part only. This is the last point from the input output exception handling we are handling. Okay. So how we are input and how we are output will generate. So we can implement this only. So let me try this one. Try something I'm trying. I'm just raising something I'm trying to raise name error. Okay, name error, and I would like to write my name over here. Okay, just for understanding purpose only, and it will raise an error. If there is an error, then it will raise an error. Okay, this it will raise an error, and then what it will do? The except keyword will generate the exception. Okay, it will print a message. I'm just printing a message. Uh, print exception is raising. Exception is okay, is occurring. Okay, simple statement I'm putting over here. No more confusion. And I need to write over here the raise. Okay, the raise to determine whether the exception was raised or not. This statement what we will do to whether is raised or not. Okay, that's the beauty. Let me check this code by executing. Okay, so name error. So this is generating exception occurring. Exception is occurring. So when the error, I'm raising an error. So what I'm doing, raise exception. This is done means manually. If you remember the my word, manually raising the error, raising the exception. Okay. So here what I'm doing, I'm manually raising the exception. I'm raising manually, but the name error. So I'm putting the my name over here just for understanding purpose only. And except keyword accepting catching the exception and printing the message exception is occurring, and this raise keyword will do whether exception is raising or not. So it's printing the message from the handling the above exception. The another exception may be occurred like this way. Okay, so this is a generated. So trace back this part is raising by this keyword raise. Okay, and the output we are printing the exception raising occurring here by this keyword. That's the point. So this is a what? This is the few things we have to keep in mind from the input output exception handling as well. So while designing any program, you people have to keep in mind what kind of the problem you have and what kind of the program you want to write. So what we have seen, if you remember the my words, what we have seen the few things which are related to the our simple concept. And what are those related concepts we have seen today? Uses data pipe as a data stream, exception and proper exception handling, and working with the directories. These are the three things we have seen today.